Okay, welcome to lecture number 25. In last lecture, we have done some factorization of quadratic equations, degree 2 equations in one variable. Today we will see factorization of quadratic expressions. Suppose we wish to factorize x square minus 6x plus 8. X square minus 6x plus 8. This has many ways of doing it, and we will see practically all the ways of doing the factorization of expressions like this. These are quadratic expressions in variable x. The first method which we are going to use today is method of completing squares, which is the most versatile method. Here what we do is, first term and second term we observe, it is x square minus 6x, and we understand, because these numbers are small, we understand that x minus 3 bracket square, if we write, first term will be x square, second term will be minus 6x, and the third term will be plus 9, and therefore we have only plus 8, therefore we subtract minus 1. So we get x square minus 6x plus 8 is equal to x minus 3 bracket square minus 1. So this can be expressed as x minus 3 bracket square minus 1 square, and then this is difference of two squares, therefore it get factorized into x minus 3 plus 1 into x minus 3 minus 1, and hence the complete factorization of given expression is x minus 2 into x minus 4. Okay, so this is fairly simple. What we need to do is just observe first two terms and complete the square, then whatever constant is remaining we adjust it properly. Let us take one more example. X square minus 2x minus 8 this time is equal to, now what will be the first step? First step, observe first two terms and find out whose square if we do, first term we will achieve. It is x minus 1, observation oral. Therefore we cross check now, x square minus 2x plus 1, and we have minus 8, therefore minus 9, right? So here again we can do it in two steps. I have added 1 here because of this square which I subtract, and original 8 is already there with for the subtraction. Therefore this becomes x minus 1 bracket square minus 9, which is x minus 1 bracket square minus 3 square, which is equal to x minus 1 minus 3 into x minus 1 plus 3. Therefore this factorization is x minus 4 into x plus 2. Okay, as the numbers are relatively small, this is very easy. When the numbers grow, what do we do? How do we find out? We will learn little later in the same video. Now another type of expressions where we need to factorize is when this coefficient is not 1. So let us see how do we go about those factorizations. Suppose I have expression 6x square plus 17x plus 5. We need to factorize this, and now here what we have to observe, I think we have learned it in the last lecture, that this 6 multiplied by 5 is the number which we have in mind, which is 30. Now can I find out, and it is a plus 30, so can I find out two factors of 30 which add up to 70, This technique we have done last lecture. Product, normally when it was 1 here, so 1 into the constant is the same constant. Earlier examples we have solved like that. But then if this constant is not 1, then we consider product of these two, which is 30 in this case, and we search for two factors of 30 which add up to 17, and we get 15 and 2. Therefore we will write 6x square plus 15x plus 2x plus 5. Here we will observe that 3x comes out to be common, which is 2x plus 5 plus 1 comes out to be common, 2x plus 5. Now 2x plus 5 comes out common, 3x plus 1. This is factorization of identities like this. Now let us take one more example and check really we can do it properly or not. 2x square plus 5x minus 12. Now here what do we need to do? 12 into 2, 24 with negative sign. Therefore one number will be positive, another will be negative. This is product of two numbers where one number is positive, one number is negative, and the bigger number is positive and the smaller number is negative. Therefore I need to find two factors of 24 whose difference is 5. So I get 8 and 3 whose difference is 5. Therefore I go 2x square plus 8x minus 3x minus 12. I take out 2x common, x minus 4 minus 3 common, x minus 4. Here I get x minus 4 common and hence 2x minus 3. This is the factorization. So if we are little alert about these numbers, in last lecture they were the last constants because coefficient of x square was 1. Today coefficient of x square is not 1. Therefore the number that we are considering is 12 into 2 with negative sign here, 5 into 6 with positive sign here, and then you search for. But then these methods also work for the numbers which are small, where we can directly find out the factors and the summation and difference of those two factors. So it is for younger kids and they should be able to do it quickly. However, if we really have numbers which are big, so hope you have understood this, you have copied it down. There are a couple of more examples of each type in the classwork, you try it at home. Now let us look at if these numbers are big and they are not good, they are so big that you cannot manipulate them the way I am doing it right now. How do we go about it? So let us take one example, and there we learn a new technique of factorization called method of improved guessing. We need to guess something and go very near to the final answer. X square minus 66x minus 5311. Suppose we wish to factorize this is equal to 0, means we need to find out values of x which make this expression 0, and unless we factorize it we will not be able to find out values of x. Therefore first job is to check how do we factorize it. So now if I want to factorize this, what I need to do is minus 5311 should be the product of two numbers. So of course those two numbers, because of this minus sign, one will be positive, another will be negative, and a bigger number is negative because 66 is negative. The difference of those two numbers should be 66. So let me check with my first guess. Suppose I take first number as 10 and second number as minus 76. I maintain this difference, minus 66. So if I observe the product of this, it is 760 negative, which is 2 less compared to 5311. So my guess is very to the lower side, so I need to improve. So maybe I take jump of 30 minus 96. Again, without actually multiplying, you can find out that suppose this was 100, still I could reach 3000 by multiplying it with 30. So if it is 100, then it is minus 3000, and therefore this would be approximately equal to minus 28,000 or so. Okay, but still it is less. So I guess one more. This is minus 104. Now I see that this is definitely more than 4,000. This is definitely more than 4,000, but still less than 5,311. Definitely. Therefore I take one more guess. 50 minus 11. Sorry, not 4 here, it is 6. Now if I observe, this is going to be greater than this because 11 into 5 is 55, is less than 53. Therefore this guess is definitely crossing this number. Now therefore I am sure If at all this particular expression has got integer root, that means two integer values of x will satisfy this, then those integers must be between these two pairs. Okay, one pair is 40 minus 106 and second pair is 50 minus 116. So, and then now I observe this is around 4000 and this is around 5500, and now I observe that 5311 is very close to 55 compared to 4000. Therefore so this is what is a big steps which I am taking, and the smaller steps I will start taking now. Suppose I take 49 minus 115. I won't do it because 9 into 5 will have 5 in the unit place, it is not there. I try 48 minus 114. Again it is not going to hit because of the unit place, and therefore I would try 47113, and now my at least unit place is telling. Therefore I go for complete multiplication, and if I multiply 113 by 47, I get 5311. You can perform this. I know that is the answer. Okay, so I could get two integers whose difference is 66 and product is 5311. Therefore my factorization will be x square minus 113x plus 47x minus 5311 is equal to 0, which means if I take x common, I get x minus 113 plus 47 common, x minus 113 is equal to 0, which implies x minus 47, x plus 47 into x minus 113 is equal to 0. Hence, x is equal to 113 or minus 47. So these are the two values of x which are integers, which will make this expression 0. Now this is called improved guessing, provided it is given that this particular quadratic equation has got roots which are integers, then only this method will work. This method is very good and requires a lot of practice for getting correct answer quickly, but this is essentially the method. You take big steps which are of first jump was of 20, then our jumps were of 10, then our jumps were of 1. So big steps, small steps, you arrive at final answer. That is what is method of improved guessing. Improved guessing will work provided the answers are integers. It is said that it is integers. So I suppose that is what is the content of this particular lecture. We have given you 4 more problems in the classwork itself which has integer roots and need to be solved by improved guessing, and there are more than 40 problems in the homework which will give you enough practice for factorizing quadratic expressions. Hope you have understood what is being discussed today. If not, see the video again, you will understand it. Try to solve as many problems as you can from the homework. If any doubt, difficulty, please ask us. Thank you.